Hello students, and welcome to today's chemistry class for S.S.1. In today's lesson, our topic will be Particulate Nature of Matter, but this will be the part 3. So, before I go into the class proper, let me tickle your fancy a bit. Do you know what the thermometer said to the graduated cylinder? He said, "You might have graduated, but I have many degrees." Do you get the drift? Let's now take a look at our lesson objectives. By the end of this lesson, the students should be able to explain Pauli's exclusion principle, Afbaus Rule, Horn's rule, and then draw the shapes of the S and the P orbitals. Explain Bohr's model of the atom. So, Pauli's exclusion principle states that two electrons in the same orbital of an atom cannot have same values for all 4 quantum numbers. Remember, we have treated quantum numbers in our previous classes. This implies that no 2 electrons can have the same values for all the 4 quantum numbers. That is, if they are in the same shell, same subshell, same orbital, then their spin must be different. Now, by those quantum numbers, I'm referring to the principal quantum number represented by N, the azimuthal or subsidiary quantum number represented by L, magnetic quantum number represented by M, and the spin quantum number represented by S. What Pauli is saying is that if these 2 electrons are arranged in this format, they will be wrong. Both of them cannot spin in the same direction. But this format would be correct because they are spinning in different directions so long as they are in the same orbital. Horn's rule. It states that electrons occupy each orbital singly first before pairing takes place in a degenerate orbital. Now, degenerate orbitals are orbitals of equal energy. That is, the p orbital has 3 degenerate orbitals: the px, the py, and the pz. They are all p orbitals. They are equal in everything except their orientation in space, their direction in space. Now, their only difference, like I just mentioned, is their orientation in space, the direction which they are facing. So, let's take a closer look at what Horn is saying. If we see this first electron, it is spinning in a particular direction. The next one will have to spin in a different direction, and on to the next, and on to the next. All this, we are currently obeying Pauli's exclusion principle. But when we come to these degenerate orbitals, where there are 3 of them and they are all equal on the same level, you will see that you will have to fill singly first, go on to the next and fill, and then to the next, before you come back and start pairing them in this format. If you do this, then we are obeying Horn's rule. Let's now take a look at Afbaus principle. It states that electrons are fed into orbitals starting from the lowest energy levels before filling the higher energy levels. So when you see us fill electrons and we say 1s2, 2s2, 2p6, 3s2, we are feeling them in order of their energies, from the lower energies going up to the higher energies. Let's now take a look at the shapes of orbitals. Like I said earlier on, the p orbital has three different orbitals: the px, the py, and the pz. Now, you can see this shape. The shape of the p orbital is called dumbbell, and this is how it looks like as you are seeing on your screen. The x orbital is horizontal, while the py orbital is vertical. You can see that the pz orbital is perpendicular to the three of them. Just think about the edge of the classroom you are sitting in, or your room. At that top edge where all the joints meet, you will see the vertical side standing as the y, the horizontal one standing as the x, then the other one that is coming, meeting it at that junction at the top of the room or the classroom that you are in. Those are the three axes that we are talking about: the px, the py, and the pz. Now, let's take a look at the shape of the s orbital. The s orbital is spherical in nature, as you can see on the screen. You can see your three axes, but the orbital goes spherical around the three axes. So now, let's look at Rudolfs model of the atom. Rutherford told us that the atom has a central core where the positive charges are situated. The protons are the ones you can see in blue, they are positively charged. The neutrons are the ones you can see in red, they do not have any charge. Now, the electrons going around the nucleus are the ones you can see in green. So, the nucleus, which is at the center, has all the mass of the atom, while the electrons revolving around the nucleus do not have any mass. We refer to this model as Rutherford's model of the atom, or the nuclear model of the atom. Going forward, let's now look at Bohr's model of the atom. Mr. Bohr said he accepted the structure that Rutherford proposed. The only difference now is he told us that the orbitals that the electrons are revolving in are not fixed, unlike what Rutherford told us. Rutherford said they were fixed, but Bohr is saying they were not fixed. That electrons can jump from one orbital to the other. When they gain energy, they jump to the higher orbital. When they lose energy, they drop to a lower orbital. Let's now take a summary of what we have learned so far. In this lesson, we learned about the structure of the atom, shapes of the s and p orbitals, Rutherford's model of the atom, Bohr's model of the atom, Pauli's exclusion principle, Horn's rule, and then the Afbaus principle. So let's now take a quick assessment. Question 1. What is the shape of the s orbital? Question 2. What is the shape of the p orbital? Question 3. State Horn's rule. Question 4. State Afbaus principle. And so with this, my dear students, We have come to the end of today's class. Thanks for watching and hope to see you in the next lesson.